Hi guys, today we are going to learn how to multiply exponential numbers. Okay, so it's a continuation of what we did yesterday, okay, working with numbers that contain exponents, what they mean. Today we're going to learn how to multiply them together. All right, so let's take a look at the do now. This is kind of just a little refresher of what we did yesterday. Evaluate the expression. We have here 3 to the 5th power. That means that we're multiplying 3 by itself 5 times. 1, 2, 3, 4, 5. Okay, and 3 to the 5th power is going to give us, just do a little quick calculation here. 3 to the 5th is going to give us 243. Okay, 243. Next one, 5 to the 4th. That means we're multiplying 5 by itself 4 times. Okay, 5 times 5 times 5 times 5. And that is equal to 625. Remember, don't fall into the trap and multiply 5 by 4 because you have 4 5s. You need to multiply 5 by itself 4 times. Okay, 10 to the 6th power. It's going to be 1 million. So that's 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6. And that's going to equal 1 million. Notice when you have a number of base 10, the exponent actually is also the same amount of zeros that you have. So notice here we have 6 zeros and the exponent is 6. That's going to be the case every time. Number 4, we have negative 4 to the 3rd power. Remember, this means negative 4 times negative 4 times negative 4. Okay, and because it's being raised to the 3rd power, we get 64. Now, should this be a negative 64 or a positive 64? Well, take a look at your signs. Remember that a negative times a negative is a positive. So if I multiply this negative times this negative, that's going to make a positive. Now I've got a positive multiplied by another negative, which means our overall answer is going to be negative. So the rule of thumb here is if you've got a negative number, negative base, and an odd exponent, your answer is going to be negative. If you have a negative base, but your exponent is an even number, your answer is going to be positive. Okay? Number 5, negative 3 to the 2nd power is negative 3 times negative 3, which equals positive 9. Again, you've got 2 negatives here. Double negative makes a positive. Okay? And number 6, even before we solve this, we can tell whether our answer is going to be negative or positive. Which one do you think it is? If you said negative, you are correct. Okay, so we have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5. And 2 to the 5th power. So 2 to the 5th power is 32, and we just said before it's negative. All right, so taking a look here, what do we notice? Let's take a look at the first one, 5 squared times 5 to the 3rd. If I write this out the long way, 5 squared, okay, 5 squared means 5 times 5, okay, and 5 to the 3rd means 5 times 5 times 5. How many 5s do I have in total? I have 1, 2, 3, 4, 5. Okay, they're all 5 to the 1st power. So I have 5 5s, which give me 5 to the 5th power. Okay, take a look at the next one here. We have 3 to the 4th power. Okay, write it out the long way. It's represented here. 3 to the second, 3 times 3. How many 3's in total? 1, 2, 3, 4, 5, 6. So therefore we can rewrite this as 3 to the 6th power. Last one, we have 2 squared, 2 times 2. 2 squared, 2 times 2. 1, 2, 3, 4. And there's your exponent, 2 to the 4th. Okay. Do you notice any common pattern here with the exponents and your final answer? So let's take a look here and rewrite these now without the expanded form. We have, for number 1, we'll put 2 and 3. 5 squared times 5 to the 3rd. Our answer was 5 to the 5th. Number 2, we had 3 to the 4th times 3 squared. Our answer was 3 to the 6th. And number 3, we had 2 squared times 2 squared, and our answer was 2 to the 4th. What do you notice about your exponents? What are we doing with the 2 and the 3 to get to 5? If you said we're adding them, you are correct. 4 plus 2 is equal to 6. 2 plus 2 is equal to 4. Okay, look at the exponents. Instead of writing out each exponential number, we can add the exponents as long as they have the same base. All right, so let's notice that's the common thread here. All right, as long as you have the common base, you can add exponents of like bases. Okay? Okay, for each of these here, 3 to the 3rd times 3 squared is equal to 3 to the 5th. 4 to the 12th times 4 to the 3rd is equal to 4 to the 15th. We are just adding those exponents to get to the exponent in our answer. Okay, product of powers property. To multiply powers with the same base, add their exponents. So that's your shortcut rule. All you have to do is add the exponents. Take a look here. We have 4 squared times 4 to the 3rd. It's the same as adding 2 plus 3, which gives us 5. If we have this written algebraically, meaning using just variables, the same rule applies. As long as you have the same base, you can add the exponents. Okay, here you can't combine m and n, so they just rewrote it as m plus n. Okay, you got a couple to try here on your own. Let's take a look at how we solve these. 3 squared times 3 squared, we're going to simply add exponents. We get 3 to the 4th power. Number 4, 8 to the 14th power. Number 5, negative 4. Make sure you have that in parentheses, and that's going to be to the 12th power. Now, why am I telling you to make sure that you have that in parentheses? Remember that if we wrote it without, it has a different meaning, okay? So just take a quick peek up here. If I write negative 2 squared, that's equal to negative 4, okay? Because it means, this means negative 1 times 2 squared. Okay, so be careful with that. If you write that with parentheses, it means negative 2 times negative 2, which is equal to positive 4. Okay, so just be aware of the difference there. Okay. Next on number 6, this should be a to the 6th. Number 7, Notice it doesn't look like we have an exponent on that h, but what's really there if we don't see it? If you said a 1, you are correct. So h to the 7th power. And number 8, 2/3 to the 8th power. Okay, so pretty simple. You're just adding the exponents every time. Again, all you have to make sure is that you have the same base, and then you can add your exponents. So what is a shortcut that we can use to help us multiply exponential numbers? As long as we have the same base, we can add exponents. Okay, and what I want you to do is come up with an example of your own. Okay, create your own example and work it out. All right, guys, I hope you found this helpful. As usual, you know how to reach me. Any questions, any concerns you have, don't hesitate to either send me a remind text or call me on Google Hangouts. Stay safe and healthy, guys, and I will talk to you soon.